Okay. Also on Schoology, okay, I put it up this morning. It should be there if you want the slides. This is 7-3, which is rational exponents. Okay. This can be tough. Okay, and I started doing this last year. I did this lesson last year for the first time with the freshmen, and I thought they handled it really well. So the bad part is I don't see them this year. I don't see them again until next year, so I won't know how it pans out. Point being, this is an Algebra 2 topic. Okay, it kind of is. Okay, this is a big topic, a big part in the Algebra 2 book. My honors kids have already done it, and my accelerated is getting almost there. So this is kind of an Algebra 2 topic. So I decided last year, let's start introing this a little bit, so that way whenever you come back to me as juniors, you know, you're big kids now, it's not so brand new. Exactly. Okay? And kind of it's a good way to start thinking about numbers. Okay? Like I said, we get away from solving equations between this chapter and the next chapter, and basically the rest of the year. Okay? There's not going to be a whole lot of solving equations going on throughout the rest of the year. So we have to change our mindset and the way we look and think about numbers, starting with this lesson right here. Okay? So, for example, a rational exponent. They are exponents that have fractions as their exponents. Shocking. Okay? You know, if you knew the definition of rational, you probably already put that together. Okay? Now, the cool part, and I mean this sincerely because I like this. I like thinking about numbers this way. Okay? Rational exponents are, does anybody know what those two symbols are up there? Square roots. Okay? Rational exponents are just square roots. Okay? They are actually all different types of roots. Okay? And here's where this is going to get, here's where some of this is going to be a little over your pay grade. Okay? Above you guys' concept level. They're actually there's more than just a square root. Okay? Did anybody know that? Like there's bigger than just square roots? Anybody know? Yeah? There's cube roots, there's fourth roots, there's fifth roots, there's sixth roots. There's all different types of roots. Okay? We won't get into those. Alright? But what you do need to know is how to change from one to the other. All the work we're going to do, since we're in the exponent chapter, we're going to do the rational exponents. Okay? So, knowing, if you look, that's the conversion. Okay? So 16 to the 1/2 power, you could just rewrite as the square root of 16. Alright? And hopefully we all know the square root of 16 is 4. Okay? Now, whenever we say these two statements are equal, that means that we can go from one form and the other form and still get there. Okay? So, we have a different type of form that we're going to do these operations with. Before we do that, though, we've got to make sure we can go from form to form to form to form. Okay? So that's what we're going to do first. So, write each expression, there we go, in radical form or in exponential form. Okay, so whatever form it's in, go to the other one. Alright, so 25 to the 1/2 power, that one's easy. All you have to do is rewrite it as a square root of 25, and it equals 5. Alright, if you can do that, if it is a perfect square, take the square root of it. No big deal. Okay? When you rewrite. Okay, now go the other way. So the square root of 18 you can write as 18 to the 1/2 power. Okay, still exponents. Those exponents are just fractions now. Okay? So number 3, 5x to the 1/2 power. Square root of 5x, good. Okay. And number 4, the square root of 8y goes to the 1/2. Okay. 8y to the 1/2. Now, this is where we kind of change the way we think about numbers. Okay? And this is where this gets really kind of, to me, awesome. Okay? This is the part, but this is brand new. Okay? Now, here's what you don't know. All right? Here's what you don't know. This little number, anybody ever seen this before? Cube root of 27. Mr. Watson, Melinda? Okay? Yeah? All right? Anybody know what the cube root of 27 is off top? No? Okay, that's fine. That's fine. That's fine. Okay? Close. All right? That's fine. You were close. Okay? Now, what it means is is the cube root of 27. This number is called the index. Okay? It's a fancy new term. This thing is called the index. And basically what it is, and all you care about, is that whenever you rewrite this as an exponential, you write it as the denominator of your fraction. Okay? That's the translation. This number goes to your denominator. Okay? That number goes to your denominator. Everybody good? Okay, now we're still going to start simplifying these, and that's where the new stuff starts. Okay? So we got to think. We got to sit here and ponder how we're going to figure this out. Okay? So I'm going to start it with this. How can you multiply to 27? 9 and 3. How else?
3.
Logan?
3.
3
Cubed.
times 3. Bingo. 3 cubed. 3 cubed. Okay? So, here's where you have to change the way you're thinking about numbers. That 27, I'm going to change the way it looks. Okay? I'm not going to change its core value, right? It's still going to be worth 27. But instead of writing it as 27, I'm going to write it, like Logan said, as 3 to the third. So this 27 is still being taken to 3 to the third. And that is still being taken to what power? The 1/3. So what do you have right here? Power to a power. And when you have power to a power, you multiply the powers. So what's 3 times a third?
1.
Multiply your numerators. 3 times 1. Multiply your denominators. 1 times 3. So 3 times to the third to the 1/3 is just 3. Okay. That's going to work for all of these. They're all going to be some sort of perfect. Okay? That's how these will work. All right? So you just have the square roots are here, right here, see? All right? Square roots are here. The nth roots, what they're called, are right here. Okay? So we're going to 3 more until we take it up to another level. A whole another level. So 32. 32, the 5th root of 32. You're going to rewrite that. That's 32 to the 1/5 power. And then you're going to sit there and go, okay, what number do I multiply together by itself 5 times to get 32? And think about this. You're getting a fairly small number, and you have to do 5 multiplications. So it's got to be 2. So you rewrite it, 32, that's 2 to the 5th, all still to the 1/5, and that gives you 2. Answer. Now, 64 is one of the greatest numbers in math. Okay, it is. First off, let's rewrite it as its power, so it's the cube root of 64, so we're going to rewrite that as 64 to the 1/3 power. Okay? As powers go, 64 is most commonly referred to what?
8.
8 what?
Squared.
8 squared. Okay? Most commonly, you know 64 is 8 squared. Does that do us any good here, though? No, because it's not a power of 3, it'd be a power of 2. No good. Okay? we need it to be a power of 3. So what times what times what is going to give you 64, Hummer? 4. Okay? So you can't just go to what you know, okay? 27, 32, fairly, you got one option, right? There's nothing, other choices. 64, you have 3 options. 8 squared, 4 to the 3rd. Anybody know the last one?
2 to the like 8.
Not 8th.
6.
6th. 2 to the 6th. Okay? But you want 4 to the 3rd to the 1/3 to give you just 4. Okay, which brings us to the next level of questions. Okay? This is what you call b to the m over nth. Okay, we're sticking with nth roots, except now the numerator won't be 1. It'll be some other number. 2, 3, 4, what have you. Okay, it'll be something else. Your denominator, this number that's going to be here, always stays as your denominator every single time. Every single time stays as your denominator. The numerator, though, is what's going to be different, okay? So if you want to write this down, go ahead, but if not, it's not. All right, so now, for new types of problems, your process is the same, okay? Your process is the exact same. You look at your denominator, and then you look at your base, okay? The first one, 64 to the 2/3 power. Your denominator is 3, and we just finished this one up. So what times what times what gives you 64? 4. So you rewrite it as 4 to the 3rd, all to the 2/3. And you still multiply them powers together. Except this time, the result's not going to be 1. Okay? It's going to be something else. So what's 3 times 2/3? 2. So now you rewrite it as 4 squared, which leaves you with 16. 36 you rewrite as 6 squared, all still to the 3/2 power, which leaves you with 6 to the 3rd, which leaves you with an answer of
120, yeah. No.
Nah.
216.
Watson?
216.
216. 6 times 6 times 6, yep. So last two rather. 27 to the 2/3. We already talked about 27 being 3 cubed to the 2/3 power, which leaves you with 3 squared, which is 9. Okay. Now 256 to the 5/4. What? You need to rewrite it with what exponent to it? 4. Okay, we need to do that. So, does anybody off the top of their head know what that would be? 64 to the 4th power. Do that in your calculator, Isaiah. You got your calculator with you today? Way to come to class. Way to come to class prepared.
I need to get batteries for it. I don't have any AAAs.
Walmart sells them every day.
I've been asking my mom already to get it out of that.
Well, here, just so you know, 64 to the 4th power is, let's see, comma, 16,777,216. I don't think it's 64 to the 4th power.
Yay!
Okay?
Is it
4,096.
okay? Is it 4?
Yeah.
256. Attaboy! Hey! But seriously though, did you see how he got that? I mean, I did the grunt work, you know. He did the brain work.
You guess.
He guessed and checked. Okay? He took this little guy and he started plugging them in. Okay? And he guessed. And he got it. All right, it's 4 to the 4th. Okay, now the reason why I'm doing this is because sometimes you will get ones that don't work out. Okay, so 256 aren't nice that you don't know off the top. 4 to the 4th to the 5/4, which leaves you with 4 to the 5th. Oh boy. Now you got to figure out what that is. Well, guess what? Huh. 724. Okay. Not 5. Why did I put 5? Solving exponential equations. All right. The other reason why I want you guys to understand how to change numbers into, like big numbers into bases to exponents, is because of this. Okay. In an exponential equation, your variables are going to be up in the exponent. Okay, they're going to be up high. The power property of equality, which is fancy talk of saying these are equal. Okay? If you have the same bases in an equation, then the powers have to equal one another. For example, that was me, wasn't it? Or was that you?
Oh, my shoe, that's me.
Okay, I was going to say, I never squeaked before. Yeah, see? Seven x equals 7 squared. If that's going to be an equal statement, what does x have to be? 2. It has to be 2. Which is the same as the exponent on the other side. Otherwise, if it's anything besides 2, they're not equal. Okay? If it's anything besides 2, they ain't equal. So it has to be 2. Now, this is predicated on this. The bases have to be the same. Okay? Now, do you think the bases are always going to be the same?
No.
No. That'd be too easy. Okay? Then it'd be like, why am I wasting my breath? The bases aren't always going to be the same. That's why I want you guys knowing how to change these numbers, because you guys are going to have these types of equations. Okay? Kind of starting off with the basic one like we did last time. Okay? These aren't going to be anywhere near the level they are in Algebra 2. Okay? I do this in Algebra 2 also. Nowhere near that level. Alright? 6 to the x equals 216. So you know the left side is a base of 6. You need to write the right side as a base of 6. Okay, so 6 to the x equals 6 to the what? It'll be x to the third. Okay? 6 times 6 times 6 gives you 216. The left side tells you what number you need your base to be. Then you make the right side happen. Okay? These will all work. Somehow, some way, they'll work. Now, to solve it, since you have the same bases, you basically, essentially just cancel them out. And you're left with the exponents of x equals 3. At its core, that's what you're doing. You're getting the bases to be the same. You're applying the property you just wrote down and canceling the bases out, leaving you with your exponents to solve for x. Okay? So when I said solving equations were gone earlier, I kind of lied to you. All right, a little bit. My bad. Okay? Everybody good? Okay. Now, obviously they won't be just the numbers like that. A little more complicated. Okay? Now, the complications to this problem hopefully are not with where you need to get your bases. You need to get your bases to what? Equal, which would be, Melinda? Didn't you say it? 5. No? Oh, someone said it. So, why? I didn't think it was that far away. Anyways, 5. Okay. 5's already 5. That's good. 25 is what? 5 to the? 5 to the second. So 25 is 5 to the second power. And it's all still to what power? The x minus 1 power, which equals 5. All right, now, let's see. 5 to the second to the x minus 1. Power to a power, you do what? You multiply. That's what we're getting to, okay? X minus 1 is what B word? Anybody know? Does anybody know that B word? Nope. Binomial. Right? Okay. So when you set this up, you have 5 times 2 times x minus 1 equals 5. So what do you have to do right here? Starts with a D. Distribute. Okay? So 5 to the 2x minus 2 equals 5. Okay? So now we have them down to the same bases. What's our issue yet right now? Bless you.
Exponent.
What's the exponent on 5?
2x minus 2.
What about the other one?
1.
1. Good. Okay? This is 5 to the first. Because we need to figure out how to set an exponent. We need to set it equal to an exponent, right? So now you can. So set your exponents equal. 2x minus 2 equals 1. And solve that equation.
Oh.
Add 2. Divide by 2. So 125 equals 5x. So we need to get down to 5. How are you going to rewrite 125? 5 to the third, which equals 5 to the x. So x equals 3. Great. All right, the second one here. 144 is what? 12 to the second, so 12 to the 2x plus 3 equals 12 squared. Set them equal. 2x plus 3 equals 2. Subtract 3, you get 2x equals negative 1. Divide by 2, x equals negative 1/2. Everybody good? Questions?
No question.
Okay. Okay, more or less, that's it. All right. Couple of things. We number 1 made it through. I'm down to 6% now. Yay, go me. Number 2, everybody good up here? Okay. Homework's going to be page 410 through 411, 17 through 55 odd. It might seem like a lot, which it kind of is, but a lot of them are practicing between going back and forth the forms and then just switching the numbers. Okay. So it's a lot in bulk. It's pretty quick though, as far as you're actually doing it. Okay, so even though it seems like a lot of numbers, the actually doing of the problems don't take you long. All right, and one of these things, I want you guys good at this, okay? So 410 through 411, 17 through 55, odd.
Yes.